Something is racing through our solar system at 130,000 miles per hour, and it's leaking metals that shouldn't even exist. NASA confirmed the data. Harvard scientists are sounding the alarm. No iron, pure nickel, and a trajectory that's just too perfect. Is this a cosmic accident, or was it sent? On the night of July 1st, 2025, astronomers at the Atlas Observatory in Chile spotted something strange. It appeared as a tiny, fast-moving speck, barely a whisper against the backdrop of stars. But when the data came in, the whisper became a scream. This object wasn't acting like anything local. Its trajectory didn't follow the elliptical paths of comets or asteroids from our solar system. Instead, it moved on a hyperbolic path, a one-time pass through our system. It's never been here before, and it's never coming back. Astronomers call it 3I Atlas, the third confirmed interstellar object ever recorded. Its orbit has an eccentricity of 6.14. For context, anything over 1 means it's not bound by the sun's gravity. This isn't a looping visitor. It's a traveler from far, far beyond. But where did it come from? Early estimates suggest its origin lies somewhere near the galactic center, possibly in one of the dense stellar nurseries filled with cosmic debris and high-energy events. And then, there's the speed. As 3I Atlas streaked into the solar system, its velocity relative to the sun was measured at 58 kilometers per second. That's 130,000 miles per hour. That's faster than any spacecraft we've ever launched. Faster than most known objects in the solar system. Fast enough to slice through like a bullet fired from the darkness between stars. By the time most telescopes even noticed it, it had already passed Jupiter's orbit and was hurtling inward toward the sun. A one-time slingshot. In, out, and gone forever. And yet, despite its speed, this object would leave behind a trail of questions that still haven't been answered. Because 3I Atlas didn't just come from another star, it brought something with it. Something we weren't ready for. At first glance, 3I Atlas looked like it might just be another icy visitor, maybe a long-period comet from the Oort cloud, but the numbers told a different story. Its speed was the first red flag, 58 kilometers per second. To the average person, that may not mean much, but in cosmic terms, it's staggering. It's more than 10 times faster than a bullet fired from a sniper rifle. It's moving too fast for the sun's gravity to ever pull it back. That speed, combined with its hyperbolic orbit, means only one thing. 3I Atlas is not part of our solar system. It is an interstellar traveler, forged in the chaos of another star system. Perhaps ejected by a violent gravitational encounter, or even by the remnants of a dying sun. But there's more. Its trajectory isn't random. In fact, it's eerily precise. When plotted backward, scientists found that it intersected a region of space densely packed with ancient stars, a place near the galactic core, where supernova, neutron stars, and extreme physics reign. Think about that. This object traveled billions of miles across space, through radiation, dust, and magnetic fields, and somehow arrived in our backyard just close enough to study, but only for a moment. This isn't a slow-moving relic. It didn't drift quietly into view. It blazed in, screaming through the darkness like a cosmic flare. And it was carrying something inside that defies everything we thought we knew about space chemistry, because what happened next was even more unbelievable. The deeper 3I Atlas moved into the solar system, the clearer it became. This was no ordinary visitor. By mid-August, astronomers using the Very Large Telescope, VLT, in Chile began studying its spectrum, breaking the light into its component wavelengths to analyze what this object was made of. What they found stunned the scientific community. The spectra revealed intense lines of atomic nickel atoms being vaporized and thrown off from the object's coma at an alarming rate. How much? Roughly 4.6 grams per second of pure nickel, shooting off into space as the object approached the sun. But here's the real shock. There was no sign of iron. None. Not a trace. Not even the faintest line. And that is a massive problem. Why? Because in every comet, every meteorite, and every interstellar dust grain we've ever studied, nickel and iron go together, always. They are born in the same cosmic crucibles, supernovae, dying stars, or neutron star collisions. They are chemically bonded in nature, paired in alloys and minerals that remain stable for millions, even billions, of years. So the idea that 3I Atlas is shedding nickel without iron is like finding a bottle of salt with no sodium. It breaks the rules of cosmic chemistry. On Earth, separating nickel from iron requires industrial refinement. We do it in specialized facilities using energy-intensive processes and magnetic separation. In nature, there's no known process that does it to this degree, and certainly not in the vacuum of space. Harvard astrophysicist Avi Loeb was the first to raise the alarm publicly. He published a preliminary paper highlighting the extreme imbalance in the metal ratios, calling the absence of iron a chemical anomaly of significant interest. In simple terms, it's weird. Too weird. According to Loeb, in typical solar system comets, the nickel-to-iron ratio is around 1 to 15. That is, for every 1 part of nickel, there are 15 parts of iron. But in the case of 3I Atlas, that ratio is off the charts, because the iron simply isn't there. And if it's not a natural separation, the uncomfortable question arises: was it engineered? Now let's be clear, Loeb hasn't claimed that 3I Atlas is an alien artifact, but he has stated plainly that the composition is unlike anything seen in natural objects. And here's what makes it even more suspicious. As the object continues to heat up while nearing the sun, it's supposed to release more volatile materials like water vapor, dust, and a mix of heavier elements. Instead, it's releasing consistent levels of pure nickel with no sign of any metallic partner. Even comets with unusual chemistry, like carbon-rich interplanetary objects, have some iron. 3I Atlas appears to have none. This anomaly isn't just rare, it's unprecedented, and it has scientists divided into 2 camps: those who think this is a new kind of natural object, formed in some extreme environment we've never seen before, like the debris of a neutron star merger or an asymmetric supernova explosion, and those who believe we may be looking at the first chemical clue of artificial origin, a manipulated alloy, released either intentionally or as the byproduct of something much more complex than a rock. But let's entertain a third possibility, one rarely discussed in scientific literature. What if this isn't a mistake? What if it's a signal? A chemical fingerprint designed to stand out, not just to instruments, but to intelligent observers. Because nickel without iron doesn't make sense in the universe we know. But it makes a lot of sense if you want to get someone's attention. Just when scientists thought things couldn't get stranger with 3I Atlas, they did. The James Webb Space Telescope, orbiting far beyond the moon's shadow, was tasked with taking a closer look. And what it found wasn't just unexpected, it was unexplainable. As 3I Atlas approached the inner solar system, Webb locked on and began capturing infrared spectroscopic data, essentially a chemical fingerprint of the gases surrounding the object. What it detected defied every comet model we've ever built. The coma, the gaseous halo surrounding 3I Atlas, was dominated by a single compound, carbon dioxide. Now, comets in our solar system do contain carbon dioxide, but usually in small amounts, about 4% of the volatile materials released when they heat up. But here, the ratio of carbon dioxide to water vapor was 8:1. Let that sink in. 8 parts CO2 for every 1 part water. Nothing in the known solar system behaves like this. The numbers were consistent across multiple Webb observations, and it wasn't just a fluke. This object was gushing CO2 at a rate of 129 kilograms per second, while releasing only 6.6 kilograms of water vapor in the same time. If you were expecting a normal comet, this would be like biting into an apple and tasting nothing but metal. And CO2 wasn't the only surprise. Other unusual gases showed up too, including carbon monoxide and carbonyl sulfide, but none of them came close to the massive CO2 spike. Here's the part that really bothered scientists. Carbon dioxide is one of the most easily altered molecules in space. Cosmic rays, ultraviolet light, and solar winds tend to break it down over long journeys. So how is it that this object, which has likely traveled for millions, maybe billions, of years through interstellar space, is still rich in one of the most fragile compounds in the cosmos? Some researchers suggest the object might have been protected, perhaps wrapped in a dense crust that shielded its inner volatiles until now. Others speculate that its chemical makeup is just fundamentally different, formed in an environment we don't fully understand. But another theory, quietly whispered in scientific circles, is far more provocative. What if the dominance of CO2 isn't just random? What if it's part of the message? Because carbon dioxide is detectable, it's distinctive, it stands out in telescope data. In fact, many SETI protocols, the search for extraterrestrial intelligence, include the search for unusual chemical signatures as potential signs of alien engineering. Could 3I Atlas have been built or chosen to display a signature that no one could ignore? Could carbon dioxide be the flag, the beacon, the cosmic flare meant to catch our attention? Of course, no one's saying this definitively. But here's what we do know. The 8:1 CO2 ratio is the highest ever recorded in any comet. The low water content contradicts every comet model we've used for decades. And the consistency of the data across multiple sessions rules out equipment error or observational flukes. So either we're seeing the most chemically bizarre comet ever born, or we're looking at something entirely different. And just like that, 3I Atlas stopped being an interstellar object and became a mystery we still haven't solved. To truly understand the mystery of 3I Atlas, we need to look back to 2017, because this isn't the first time something strange has slipped into our solar system and defied every expectation. Its name was Oumuamua, Hawaiian for a messenger from afar, arriving first. And it was the first interstellar object ever detected. At first, astronomers thought it was just an elongated asteroid, but the deeper they looked, the weirder it got. Oumuamua wasn't emitting any gas, dust, or water vapor. There was no tail, nothing to suggest it was a comet. Yet somehow, as it passed closest to the sun, it accelerated. Now, acceleration in space is a serious thing. According to physics, an object can only change speed if something is pushing it, like outgassing from a comet or gravity from a planet. But Oumuamua had none of that. It changed speed without explanation. Its shape, even stranger. Its light curve suggested it was either a long, narrow cigar or a thin pancake-like disc, something 10 times longer than it was wide. Unlike anything we've ever seen naturally, scientists scrambled to explain it. Some suggested hydrogen outgassing, invisible to our instruments. Others speculated about exotic ices or even fractal dust, but none of the models fit all the data. And that's when Harvard's Avi Loeb stepped in. He published a controversial paper proposing something radical, that Oumuamua could be a solar sail, a thin, lightweight structure designed to harness the pressure of starlight for propulsion, a technological artifact. In other words, something engineered. The idea caused a firestorm in the scientific community. Critics dismissed it as science fiction, but Loeb stuck to the evidence. The acceleration, the shape, the lack of outgassing, the trajectory. Too many anomalies for a rock. Sound familiar? Because now, years later, 3I Atlas has entered the scene, and it's exhibiting its own set of impossible characteristics. An interstellar origin, a velocity that defies capture, a chemical composition that doesn't match any known comet, a suspiciously perfect trajectory through key planetary orbits. And suddenly, the memory of Oumuamua doesn't feel like a one-time oddity. It feels like a pattern. Two interstellar objects, both radically different from anything we've seen, both displaying unexplained behaviors, both showing up just years apart, after centuries of seeing nothing like them at all. It raises a haunting question. If one object breaking the rules is a coincidence, what's two? Is it possible we're witnessing a series of intentional arrivals? Objects designed not to communicate with radio signals, but to leave physical traces. Puzzles encoded in matter, chemistry, and motion. Of course, we don't know, but we do know that each new visitor has pushed the boundaries of what we thought possible. And the similarities between 3I Atlas and Oumuamua can no longer be ignored. Maybe they came from different systems. Maybe they came from different events. Or maybe they didn't come by chance at all. Long before telescopes, before satellites, before the idea of space even existed, humanity was already fascinated by something falling from the heavens. Metal. Not just any metal, but iron, unlike anything they could find on Earth. Smooth, shiny, harder than stone, and unmistakably otherworldly. In ancient Egypt, it was called iron from the sky. To the pharaohs, it wasn't just rare, it was sacred. Over 5,000 years ago, archaeologists uncovered tiny iron beads in graves near the Nile, meticulously shaped into tubes and bracelets. Modern analysis revealed something incredible. These beads contained over 30% nickel, far more than any Earth-sourced iron. The verdict was clear. This iron came from a meteorite. And the story doesn't stop there. In the tomb of King Tutankhamun, a ceremonial dagger was found, beautifully crafted with a golden hilt and an iron blade. For years, its origin remained a mystery, until researchers analyzed it using X-ray fluorescence. The result? The blade contained 11% nickel and trace amounts of cobalt. Again, a chemical signature of meteoritic iron, not Earth-forged metal. Even more astonishing, the blade preserved its Widmanstätten pattern, a delicate crystalline structure formed only when iron cools extremely slowly in the vacuum of space over millions of years. That means whoever crafted it, thousands of years ago, knew they were working with something not of this world. And it wasn't just Egypt. Across Bronze Age civilizations, in Syria, Turkey, and China, artifacts made from sky metal appear again and again. Axes, daggers, jewelry, all sharing one common trait, a high nickel content and isotopic fingerprints that trace back to the stars. It seems our ancestors didn't just discover space metals, they revered them. In many cultures, meteoritic iron was valued more than gold, reserved for kings, warriors, and gods. To them, it wasn't just metal, it was a gift from the heavens. Now fast forward to today. We see an object, 3I Atlas, shedding pure nickel with no iron in quantities and ratios that don't exist naturally on Earth. And whether we admit it or not, we're reacting just like the ancients did. Fascinated, confused, in awe. Is this a coincidence, or are we seeing a new chapter in an ancient story? A story where metal from the stars carries more than just mass and density, but meaning. Because here's a thought. If ancient civilizations saw value in sky metal, what might an advanced civilization be trying to say by sending us something like 3I Atlas? Is it just a cosmic rock, or is it a symbol, a piece of a pattern that stretches across time and civilizations from the dawn of humanity to the edge of the galaxy? At this point, you might be asking, is there any way this is natural? Could something in the universe, without technology, without intelligence, have created an object like 3I Atlas? It's a fair question, and the answer is maybe. But if it did, the process would have to be one of the most violent and extreme in the cosmos. Let's explore the two leading theories that scientists have proposed. In 2017, astronomers witnessed something breathtaking. The first confirmed kilonova, the result of two neutron stars spiraling into one another and colliding in a catastrophic explosion. This event, called GW170817, was so powerful that it briefly outshone an entire galaxy. But what's more important for us is what it produced. In that moment, dozens of heavy elements were born, including nickel. Not the slow-cooked metals from red giants, but exotic isotopes forged in milliseconds by a process called the R process, rapid neutron capture. In a kilonova, atomic particles are packed so densely and smashed together so violently that the laws of chemistry almost break down. The result? A chemical stew that can be wildly unbalanced. Some models suggest that the ejecta from such a collision could contain clumps of nickel-rich material with little or no iron at all. That matches what we're seeing in 3I Atlas. And because kilonova debris drifts through the galaxy for billions of years, a chunk could, by pure chance, end up crossing our solar system. It's possible, but the odds, slim. Like finding a single glowing ember from a dying star across light years of empty space. Another natural possibility lies in the chaos of dying stars. When a massive star collapses and explodes in a core collapse supernova, things don't always go evenly. In fact, they often go violently wrong. Observations of remnants like W49b have shown supernovae that explode asymmetrically, meaning different elements are launched in different directions. In W49b, scientists observed nickel-rich jets blasting out of one side of the star, while iron stayed packed tightly in the core. If a fragment formed from one of those jets, it could be nearly pure nickel, with little or no iron. Over millions of years, that fragment could cool, solidify, and drift through the galaxy until it eventually found us. Again, this scenario matches the signature we see in 3I Atlas. And unlike kilonovas, supernovae are more common. But here's the problem. Even in asymmetric explosions, the separation of elements isn't perfect. Most nickel is still accompanied by some iron. The complete absence of it in 3I Atlas remains deeply unusual. So yes, nature might be able to create something like this, but it would be rare, very rare, almost too rare. And that's where the mystery deepens. Because when the only natural explanations require cosmic-level violence, perfect timing, and near-impossible chemical imbalances, you have to wonder, is it just an extreme coincidence? Or are we missing something? Something that wasn't created by chance, but by choice? So far, we've talked about what 3I Atlas is made of. We've examined its nickel-heavy, iron-absent composition, its bizarre carbon dioxide spike, its possible birth in some of the most violent cosmic events imaginable. But there's one more clue, one that doesn't lie inside the object, but in how it got here. Let's talk about its trajectory. When scientists at Harvard and other institutions ran orbital simulations of 3I Atlas, they discovered something highly unusual. On its brief journey through our solar system, the object passed shockingly close to Venus, Mars, and Jupiter, 3 key planets, each within a narrow margin of approach. How narrow? Close enough to be noteworthy, and rare enough that the statistical odds of it happening by chance are 0.005%. That's 1 in 20,000. To put it another way, it's like flipping a coin and getting heads 15 times in a row. Now let's be clear, rare things happen in space. Statistical anomalies occur, but this isn't just rare, it's precise. And it gets weirder. The trajectory of 3I Atlas is retrograde. It moves against the natural flow of planets in the solar system, and it's inclined just 5 degrees off the solar orbital plane, meaning it's nearly flat, skimming the same region where the planets orbit. Think about that. It's not diving in from above or below. It's sliding through our system, sweeping past multiple planets like a flyby reconnaissance mission. And here's the kicker. 3I Atlas reached its closest point to the Sun. It's perihelion, on the far side, hidden from Earth's best observational points. In other words, it was brightest and closest when we couldn't see it well. Coincidence? Maybe. But some scientists, including Loeb, are asking a bold question. What if the trajectory was not random, but intentional? What if this object wasn't just ejected from some chaotic supernova, but aimed, not necessarily by aliens in a spaceship, but by some form of automated process long ago, designed to send a message or gather information, or maybe even observe us? Loeb compares it to a survey path, one that cuts across multiple orbits, collecting data without being obvious, and then disappears. If this object were part of a natural population of interstellar debris, we'd expect to see hundreds mere like it. Instead, we've seen 3, ever, and 2 of them, Oumuamua and 3I Atlas, both showed anomalous behaviors and questionable paths. Now, to be clear, there is no direct evidence that 3I Atlas is a probe, or an engineered craft, or anything of that nature, but the alignment, the speed, the geometry. It's starting to look like a pattern, or at the very least, it's enough to warrant a closer look, because if that path wasn't an accident, then 3I Atlas didn't just pass through our solar system, it came for it. Let's step back for a moment and ask something simple, but radical. What if 3I Atlas wasn't just a rock? What if it's a message? Not a message in radio waves, not a signal sent through lasers or electromagnetic pulses, but something far more durable, something that could last billions of years, immune to noise, decay, and time itself. A physical message. In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record, a copper disc engraved with music, languages, scientific diagrams, and even images of Earth. Why? Because someday, maybe in 1,000 years, maybe in 1 billion, something or someone might find it, and when they do, they'll learn who we were. That was our message in a bottle, our fingerprint cast into the void. But what if someone else did the same? Not with a disk, but with matter itself. Think about it. Every alloy, every ratio of elements, every isotopic abundance inside 3I Atlas could be information. a chemical archive deliberately crafted and launched across space, waiting to be discovered by a civilization advanced enough to recognize it. Not all life forms would communicate the way we do, but every intelligent species understands chemistry. Every civilization, no matter its form, would learn the periodic table. So instead of sending messages in sound, why not send them in atoms? This isn't just a sci-fi concept. On Earth, we already encode information using molecules. DNA is nature's hard drive. We use isotopes in medicine, forensics, and nuclear science to trace events, timelines, and origins. Advanced civilizations could, in theory, create objects with specific elemental signatures, using stable isotopes and controlled compositions to store data in a way that would last forever. Imagine an object built to mimic a comet, but instead of being formed in randomness, it was built with intention. Each deviation from natural chemistry, like pure nickel without iron or an overwhelming carbon dioxide spike, isn't an accident. It's a code. Maybe we don't have the key to decipher it yet. Maybe we're like early humans staring at hieroglyphs, unable to read them, but certain they mean something. And if that's true, then 3I Atlas is more than a mystery. It's a messenger, not broadcasting, not pinging us with lights or sound, but existing silently, in a way that makes us stop and look twice. That alone is powerful, because sometimes the best way to communicate across the stars isn't to speak, it's to send something that shouldn't exist. And wait. We've talked about metal, we've talked about trajectory, we've talked about what's there and what's missing, but now scientists are beginning to look even deeper, not just at what elements are in 3I Atlas, but at their isotopes. You see, every element comes in slightly different versions, atoms with the same number of protons but a different number of neutrons. These are isotopes, and their ratios are like fingerprints. They can reveal where and how something was formed. On Earth, isotopic analysis is used to trace nuclear weapons, solve cold cases, and even study climate change through ice cores. In space science, it's no different. Now, labs around the world are starting to analyze the nickel isotopes and carbon compounds in the gas cloud left behind by 3I Atlas. And guess what? Some early readings are showing abnormal ratios, not just rare, unnatural, not consistent with supernova debris, not matching known meteorites, not like anything we've cataloged. Are these just odd quirks of cosmic chemistry, or are they encoded? There's a concept floating around among some astrophysicists. Speculative, yes, but grounded in logic. What if the message isn't in language, but in mass? If a civilization wanted to create a durable, passive message, it could encode it in isotopic ratios, the number of neutrons in a given element. Subtle, elegant, nearly impossible to replicate by chance. Think of it as an atomic QR code. If someone or something wanted to prove its intelligence, they wouldn't need to send signals. They could send matter with structures that nature couldn't imitate, ratios that scream, "This was made." It's not science fiction. It's what we already do, on Earth, in our labs, with our technology. So the real question is, are we just now catching up to a message that was sent long before we knew how to read it? Because if the isotopes in 3I Atlas show patterns that defy natural explanation, then we're not just analyzing a rock. We're decoding a signature, one written not in words, but in the building blocks of reality itself. And just when you think the mystery of 3I Atlas can't go any deeper, there's one last detail, something hidden. Something most people have completely overlooked. It might be the missing piece, or the beginning of something even bigger. Click now. before someone else finds it first.